Hey everyone, let's do some introduction to partial differential equation. Here's the problem. What are the values of a and b so that the function u equals e raised to ax plus bt is a solution to the heat equation? The partial derivative of u with respect to t equals the second partial derivative of u with respect to x. Now let's solve this problem together. Let's begin by noting that when we say partial differential equation, these are equations relating the partial derivatives of some unknown functions. And these some unknown functions are the solution to the differential equation. In other words, we have here this differential equation, and we are saying that this function u is that unknown function that is the solution to this heat equation. So in order for us to show that this function u is a solution to this heat equation, we need to find the partial derivative of this function u with respect to t, and we want also to find the second partial derivative of the same function u with respect to x, and those two partial derivatives must be equal. Now, before we solve our given equation, let's begin first with something that's simpler. Let's say u is equal to 1/2 x squared plus t. And let's suppose that this polynomial equation is a solution to our partial differential equation. This function u is a solution to this heat equation. So we need to find what is the partial derivative of u with respect to t, and that is equal to, we are going to differentiate this with respect to t, which is equal to the derivative of this by letting the other variables other than t to be constant. That means we will take this x squared as a constant, and therefore the derivative of the first term is 0, and the derivative of t is 1. Then we need to find what is the second partial derivative of u with respect to x. So we need the second partial derivative of u with respect to x. But before we can get here, we need first the first partial derivative of u with respect to x. So that means we are going to differentiate this by taking all the other variables as constant and only differentiating with respect to the variable x. That means the first derivative of this would be 2 times 1/2 x, which is equal to x, and the derivative of t is 0, and the derivative of this derivative is the second partial derivative of u with respect to x, and that is also equal to 1. So we have shown that the partial derivative of u with respect to t is equal to 1, and the second partial derivative of u with respect to x is also equal to 1, and that satisfies this heat equation. And therefore, we now say that u equals 1/2 x squared plus t is a solution to this heat equation. In fact, we call this as the heat polynomial, which is one of the solutions of this heat equation. Now, going back to our main problem here, if our u is e raised to ax plus bt, we need to find the value of a so that we can satisfy this heat equation. So we need to find first what is the partial derivative of u with respect to t, where our u here is this equation. So in order to compute for the partial derivative of this with respect to t, this variable x is constant. The derivative of e to the exponent is e to the exponent, so e raised to the exponent ax plus bt times the partial derivative of the exponent ax plus bt with respect to t. That means this x is 0, so the derivative with respect to t is b, so times b. Now we need to take the second partial derivative of u now with respect to x. But before we can go here, we need first the first partial derivative of u with respect to x. We can also call this curly d as del, so we can read this as del u del x. So what's the first partial derivative of u with respect to x? So we have a function e raised to the exponent ax plus bt times the partial derivative of the exponent with respect to x. So this bt becomes 0. The derivative of ax is a, so times a. Now the derivative of this first partial derivative is the second partial derivative of u, and this is equal to this function e raised to ax plus bt times a times the partial derivative of the exponent with respect to x, which is also equal to a. So this becomes now a squared. Now we need to equate these two expressions, this one and this other one, and find the value of a and b that will satisfy the equation. So we have e raised to ax plus bt times b equals e raised to ax plus bt times a squared. Now, since the base is e this exponential expression here cannot be equal to 0, and that is the same as this exponential expression here, then we can cancel these two out. And so we have b is equal to a squared. So when b is equal to a squared, then this function u equals e raised to ax plus bt becomes a solution of this heat equation. And so this is the required relationship between a and b that can satisfy this partial differential equation. We'll have more examples of partial differential equations in our next videos.